This one's shorter, that's the negative. Think of the short, looks like the negative sign. So negative end, this is the positive end. So here we have resistor 1, R1, resistor 2, R2, resistor 3, R3. So the current, remember the current is that flow of electrons. That is going to be the same throughout all the resistors because there's no other path for the electrons to flow. So they have to go through those resistors. And the resistors, that current will be the same for all those resistors. The voltage then is going to be split between the resistors. R equivalent is equal to R of 1 plus R of 2 plus R3. So we have voltage, current, resistance. So then that means the current is equal to the voltage divided by the resistance. And if we have multiple resistors in a circuit, it would be the equivalent resistance. We just add them all up. So it'd be voltage divided by the equivalent resistance. Series circuit. Okay, because the electrons, remember the electrons are negative and they're going to flow. This is the direction they flow. However, when we're talking about the conventional way to demonstrate the current flow, it's opposite the direction the electrons are flowing. But if we're looking at just the flowing of electrons, they have to go through these pathways. They have to go through this resistor. They have to go through this one. They have to go through that one. It's a little counterintuitive because you know that electrons are negative. They're always going to be going toward the positive end. They're negatively charged. Electrons are negative. Everybody knows this. They're going to go toward the positive end. However, when we're looking at currents in circuits, we're going to be using the conventional method to determine the direction the current travels, which is counterintuitive. It's actually going to go opposite the direction the electrons flow. So if we go opposite, we're going from positive to negative. And when we go from positive to negative, we would be going this way. That's why these are numbered 1, 2, 3. The opposite the direction the electrons flow. So 1, 2, 3. The electrons have to flow through these resistors. All right, so this is a closed circuit, and it's a series circuit because their resistors are in order. They have to go through all of them. R equivalent is going to equal R1 plus R2 plus R3. Okay, let's say we're given the resistance. Okay, so we're going to give it an example here. This is a practical. We're going to say resistance 1. We are told it's 300 ohms for R1. Remember, ohms, we use an omega sign to indicate that. So it's 300. Resistor 2 is 300. Resistor 3 is 400 omega. Okay, so now we're given the resistance of 1, 2, 3. We can add them up and get the equivalent resistance. So let's do that. 300 plus 300, 600 plus 400 is 1,000 ohms. So now we want to figure out what's the current. Okay, we now know we have this many volts and we have this much resistance. We want to figure out what's the current. So we want to solve for I. Same thing, we're going to take the voltage divided by the equivalent resistance. So voltage is 1,000 volts and the resistance is 1,000 ohms. 1 ampere or amp. So the current is 1 amp. So if you have a series circuit, one after another, okay, so the electrons have to go through all of the resistors. So a series circuit has multiple resistors and they are in order, 1, 2, 3. Electrons have to go through all of them. Okay, and